Okay, so today we're doing 5.7, Systems of Linear Inequalities. So in the last section, we talked about linear inequalities, and we looked at graphing y equals mx plus b. We made it a solid line if it was including that, so if it's greater than or equal to or less than or equal to, and it was a dotted line if it did not actually include the line, so that was if you had less than or if you had greater than. And we talked about shading on one side or the other. So today we're going to look at what happens when we have a system of linear inequalities. So that's going to be when you have two or more linear inequalities. So we're going to be, just like when we were solving systems of equations, we had two or more equations, we wanted to know where it worked for both equations. Now we're going to be looking at when we have two or more inequalities and where does it work for at least one of the for both of the inequalities. So the solution is going to be any ordered pair that works for both of your inequalities. And you're going to find out it's not just a single coordinate point, it's going to be an entire region most of the time that we're going to be shading. So the graph of your system of linear inequalities is going to be the graph that shows all of your solutions to that system. So step 1, graph each inequality. Step 2, find the intersection of the half planes. In other words, where did you shade for both of them? So you're going to shade on one side of the first line and then you're going to shade on one side of the second line. Your answer is going to be the region that was shaded for both of them. Okay. So if we get started with these first ones, it just says tell whether the ordered pair is a solution to the system of linear inequalities. In other words, does it work for both of them? If it works for both of them, then it is a solution. If it doesn't work for both of them, that means if it works for one or if it works for neither of them, then it's not a solution to that system. So if we plug in on the first one 0, 0, well, there's no x on our first inequality, so it just becomes 0 is greater than 2. 0 is not greater than 2. I don't even have to check the second one because it did not work for the first one. I can say no, that coordinate point is not a solution. For the second one, I will plug in a negative 1, 1. So I'll plug in a 1 for my y. Is 1 less than 3? Yep, so it works there. So if it works for the next one, we know it'll be a solution. So I'll plug in a 1 for my y, a negative 1 for my x, and I get 1 is greater than negative 5. This is also true, which means that coordinate point is a solution. Okay. So now we're getting into actually graphing our systems. So this is a system of linear inequalities, so we're going to be doing shading for both of them. So if I have y is greater than negative 2, greater than negative 2 does not have an equal to sign underneath it, so I know it's going to be a dotted line where y is equal to 2. And then I need to pick a point above or below it, not on the line. Again, I like to pick 0, 0. So I have 0 is greater than negative 2, which is true. So that means I'm going to shade everything above this line. Okay, so now I'll go to the second one. So I have y is less than or equal to 3x. So this one has a y-intercept of 0. And it has a slope of 3. So I go up 1, 2, 3, and right 1, or down 1, 2, 3, left 1. This one's less than or equal to, so I will connect it with a solid line, not a dotted line this time. And then again, I need to pick a point. This time I can't pick 0, 0 because 0, 0 is actually on that line. So I'm going to pick the point 1, 1. So I'll pick this point right here. So if I plug in a 1 for y and a 1 for x, I end up with 1 is less than 3, which is true. So that means I'm going to shade everything on this side of the line. So now take a look at my graph. Where do I have shading in both pink and in purple? Well, it's going to be this top upper right-hand corner. So I need a different color, and I'm going to show that my solution set is everything that's shaded up in this section up here. So all the way down to that line, all the way over to this line, that's going to be my solution set. And you actually have to erase the shadings in the other regions. So get rid of my other shadings, and that is what my solution set is going to look like. I should have put my arrows on this line. There we go. Okay, so that means any point in that black shaded region is a solution to that system of linear inequalities. Okay, so let's take a look at the next one. So I have y is less than 3. Y is less than 3 is going to be a dotted line where y is equal to 3. I'm going to pick the point 0, 0. Again, that's the one I always like to pick if it's not on my line. So I get 0 is less than 3, which is true. So I'm going to shade everything below that line. Okay, next I have x is less than 2. So where x is 2, this is also going to be a dotted line where x is equal to 2 would be a dotted line. If I pick the point 0, 0, I get 0 is less than 2, which is also true, which means everything on this side of the line is going to be shaded. So then I take a look, where did I shade for both pink and purple? That's going to be my final solution set. So that was everything on this side over here. So up until this line here, up until that line, and shading everything in the middle. And then again, I want to make sure I go back and erase the ones that was not part of my solution set. Okay. Take a look at the next one. So the next ones, they've given us a graph and we're asked to write what the system is going to look like. So we're wanting to write what the two inequalities are going to be. So let's take a look at our first one. So my first one, if I take a look at this dotted line right here, that is the line x equals 2. Now I'm not going to put my equal to sign because I know it's an inequality. I have to decide, is it going to be less than or greater than? So again, I'm going to pick the one I think it's going to be. I think it's going to be less than. So then I pick a point on the side where it is shaded over here. If I plug that point in, 0 is less than 2 is true, so I know I've picked the correct sign. If I plugged in a point on the shaded region and it didn't work, I know I just need to flip my inequality. So then let's take a look at our solid line. Solid line here. That's going to be the line y is equal to 3. And again, I'm not going to put the equal to sign. I'm going to figure out which inequality. Let's say I chose greater than for this one. So if I plug in a point that's in the shaded region for this one, 0, 0, plug it in, 0 is greater than 3 is false. So that means I picked the wrong one. It needs to be y is less than 3. So my system is actually going to be both of these together. Okay, go ahead and try number 10. Notice the region that's shaded darker in this middle section here. That's where it's shaded for both of them, which means everything for this line was shaded above it, and everything for this line was shaded down below it. So see how you can do on this one. Okay, so I'm going to start with this dotted line here. That's the line y equals 1. Everything is shaded above it, so that's going to be greater than. And again, I can pick a point and make sure it works. So if I plug in this point here, 0, 2, and I plug in a 2 for y, 2 is greater than 1 works. So that's one of my inequalities. And then if I take a look at this line here, that's the line y is equal to 3. It's everything shaded below it. So if I pick the point 0, 0, then I can figure out which sign it's going to be. So if I plug in a 0, 0, 0 is less than 3 does in fact work. So there's my second inequality. All right, let's check and see how you did on number 11. All right, so on number 11, let's start with the solid line here. This one is y equals, has a y-intercept of 1 and a slope of 1. So that would be a 1x plus 1 or just an x plus 1. It looks like I have shaded everything above it because everything up here is shaded. So that's going to be above is probably going to be greater than, but let's check it and make sure. So if I shade above this line, then that would be the point 0, 2. So let's see if that works. So I get 2 is greater than 1 plus 1 is 2. Hold on. What did I not do correctly? Because I should have a clear answer. Let's see. So y-intercept of 1, a slope of 1, that's correct. I'm shading everything above it, so that'd be the point 0, 2. 2 is not greater than 2. Oh, doy, that's why. It may catch my mistake. You guys are sitting here listening to me ramble on, and you're sitting there going, I know what the problem is. My problem here is that's not 2. 1 times 0 is 0. 0 plus 1 is 1. There we go. Okay. So we all make mistakes. Again, I'm able to figure it out, and that's the important part. If you're not ever able to figure out what you did wrong, that's okay. Just ask a question and I can help you with it. So I picked the right sign. So that is my first graph, my first equation. So then for the second one, my dotted line has a y-intercept of 1 and a slope this time of -1. So it'd be y equals -1x plus 1. It's shading everything to the left of it. So again, I think that that's going to be a lesson, but let's check and make sure. So this time I can pick the point 0, 0. And when I do, I get 0 is less than 1, which is true. So again, I have picked the correct inequality sign. Remember, it's okay if you pick the wrong inequality sign first. Once you check it, you see it's a false statement, then it means you just need to flip your inequality sign. Okay, so instead of doing this last example here, I want to talk about a couple of special cases. So what happens if I have a graph and I have parallel lines and I have shaded everything to this side of this one and I've shaded everything to this side of this one? What would the solution set be? That's going to be no solution because there is no place where they overlap. Okay, so keep that in mind when you're dealing with your special cases. If there is no region that's overlapped, then that means that no region actually works, so it would be no solution. Okay, take a second and write your summary. Mark down any that you have questions on, and then come to class prepared to get those questions answered.